Welcome to lesson 2 and topic 2, talking about our review of linear relationships. And like I said, this is a review. So today's lesson, I'm going to let you know, is going to go very fast. We're going to be using some information from going to an arcade, much like going to the bowling alley, but we're really going to be focused a lot on linear relationships in tables. As a warm-up, what we're after with this and our learning goals is we really need to understand that the rate of change is read from the x and y values from a table. We're going to be looking at the slope formula for how we calculate the slope of any tables of value, and then we're going to figure out if a table of value is proportional or non-proportional. We're also going to find out if a table of values is linear or not. So we're going to go ahead and review those things. We're also going to be introduced to a term called first differences. We'll see how that works out. Very first thing, quick reminder as we do our warm-up, the slope of any line, we can find the slope of any line by taking any ordered pairs that we would call integer ordered pairs. We call them integer ordered pairs because we can look right here. If we're looking at the x-axis, this is -6 and the y-axis is -8. We look at that ordered pair, comes out at integers where it crosses the line. We can find that same type of situation all the way up this line, and then we can find the slope by connecting those dots in a series of right triangles. And what we see is a constant pattern that's evolving where we rise 1 and we run 2. So the slope of line A is equal to a rise 1, run 2. We can actually find any ratio that's going to be representing the exact same thing, and that ratio will always come out to a slope of 1/2. For instance, if I took from right here at this point, and I went ahead and I came up to right here and over to right here, right here, I would see a rise of 5 and a run of 10, which gives me a slope of 5/10. Now, line B is just a little different. I see the line B actually appears to be decreasing, which is a dead giveaway that it's a negative slope. But I need to figure out how that negative slope works out. When I start here at the very top and I come down to my next integer crossing, I see that I'm decreasing at a rate of 3 and increasing at a rate of 1, so my line is a -3 over a +1. Perhaps if I went from the first one, I'm going down by 6 and then to the right 2, and we see that those two fractions are the exact same, so a slope of -3. Okay? So the question is, how do you calculate the slope of a linear relationship when you're given a table of values without actually creating a graph? Let's look. One of the important things to look at is that we should be able to estimate those values, and I think to be able to estimate those values means that we should actually recognize what a positive slope and a negative slope looks like. As we've seen in the past, remember that under that slope, when we see an increase from left to right, we see a positive slope, and a decrease we see from left to right is a negative slope. But don't forget that there's also slopes that have a flat line. That line means that there's zero slope happening there, even though this slope can still be represented. If we're going to match up these tables to any of these 4 slopes that are given down here below, what I should be able to recognize is what those slopes will look like. A slope of 1 always crosses through at 45 degrees. Likewise, a slope of -1 is going to have a line that's also down to 45 degrees. Something to remember about that piece is the further away from 1 that we go, where a line is less steep, we recognize that it's getting closer to 0, so it will have a much smaller slope. Therefore, smaller fractions will actually be less steep of a line. In this case, when we're talking about a slope of 1/4, A isn't very steep. It's actually less than 45 degrees. This one, I would say graph A is probably a slope of 1/4. And I look through B, looking at that one, it's decreasing. That's a negative slope. It's a pretty steep negative slope. And I want to look at my options. I see D is the only negative slope. That means graph B is a -3. Graph C has just a flat line. It's a horizontal line. We know it's not increasing at a rate of 1 and running 4. It's not increasing at a rate of 5 and running 4. It's certainly not a negative slope. This leaves us with a slope of 0 for C. D, again, another negative slope. So graph D is a -3. Graph E is much steeper than graph A is. We see that this one is actually greater than 45 degrees, but just slightly. 5/4 is just slightly greater than 1. Graph E has a rate of 5/4. And finally, graph F, a very gradual, not nearly as steep as E, much less steep. It would be more reasonable to call that a slope of 1/4. So how did you use the graphs to estimate their slope? Think about that concept. 1/4 is not very steep. It's less than 1. So it's going to be less than 45 degrees. B, negative slope. Has to be matched up with the negative slope. But again, it's also a very steep negative slope. Graph C, it's not sloped at all. There's zero slope to it. So that's a pretty easy one to recognize. So let's get into this piece about Ron and talking about this arcade concept. We're going to look first at a whole bunch of information about slope from a graph, and then we will compare that and find slope from a table. And they better match up. So first thing, Ron he has a player's card for the arcade, and his player card keeps track of the number of credits he earns for the winning games. This is much like the bowling alley we have here in town, where you have your playing card, you put a bunch of money on it, and it keeps track of the number of tickets that you win for any games that you do well on. Each winning game earns the same amount of credits. That's a big deal right there. Earns the same number of credits. We know that that's a constant rate, and that Ron has been saving his credits. His goal is to get to 500 credits. The table and the graph show the exact same information. It shows the number of credits Ron had on his game card at various times in the day when he checked his balance throughout the day. Question, the very first thing we need to ask is going back to proportional or non-proportional. Remember that a proportional relationship has one very big concept that makes it distinguished from non-proportional. Proportional relationships always pass through the origin. Always pass through the origin. It means that the output, y, is being directly influenced by the input, x. In this case, we see that our line does not pass through 0, 0, so we know this is non-proportional. And then we could just say, does not pass through 0, 0. So 0, 0 is not a solution. But it does pass through at 0, 20. So explain the meaning of the order pair 0, 1, 20 listed in the table right here. What does that mean? Well, if we look at 0 and 120, we know this is the x-coordinate 0. The y-coordinate is 120. Corresponding up here in the table, that means that the number of games is the x-coordinates, and the number of credits is all the y-coordinates. So what does that mean? Well, Ron hasn't played any games yet today, but he has 120 credits. So that means that his beginning credits is 120. Or after playing 0 games today, Ron hasn't played any games today, but he starts out with 120 credits. Something about that to talk about his initial value. If we use the graph, we're going to determine the slope of the line, then explain the meaning of the slope in terms of the problem situation. Going back to what we did in the warm-up, we found a couple of integer pairs. So right here is a nice little intersection, and right here is a nice little intersection. I think there's also another one right here, and let's see if we can establish something based on our slope triangles. We see that from 120 to 200, that's increasing by 80. And then right here, it appears that we're going 0 to 4 skipping line. This must mean that that's 2, 4, 6, 8, 10, 12. We see that those lines the intervals are of 2s on the x, 40s on the y. So we see that we have an increase of 80 over 2, 4, 6, 8, 10. Let's make sure that that's the same thing all the way through. Increase of 80 over 2, 4, 6, 8, 10. 40, 80, 2, 4, 6, 8, 10. I think that's a pretty well established fact that my slope is 80 over 10, which simplifies to 8 over 1. You'll notice that I left a really big line there because I'm supposed to explain the meaning of the slope in the situation. So it means I need to tell the story. Well, if I'm telling that story, the top number is the change in y. We know that y represents the number of credits that are on the card. And then we have the change in x, which is the number of games won. If I look at this and I say 8 credits for every 1 game won, that means that he's earning 8 credits for every winning game. Pretty simple, right? So 8 credits earned per 1 game won. Awesome. Well, Ron has this friend named Rhonda, and Rhonda's reasoning is right here is that 440 credits divided by 40 games won means that he gets 11 credits per game. So notice here it says, explain why her reasoning is incorrect. Well, Rhonda is wrong. So let's talk about why she is wrong. Let's look at what she did. She did 440 divided by 40. Where do we see 440 divided by? Well, I see right here 440 and 40. She simply divided the output divided by the input. I think the issue is right here is that Rhonda believes that this is a proportional relationship. Rhonda has forgotten that Ron didn't start out with 0 credits. He started out with 120. And so she simply did a y divided by x, assuming that this information or these data were proportional. And the problem is that they're not proportional because the information does not pass through the origin. Plain and simple. Rhonda is wrong because she thought that this was a proportional relationship. Not true. Okay? Thought the data was proportional. But it's not. Whoop. Nope, no comma right there. Okay. So before Ron started winning his game today, how many games had he won for each or for which he had saved the credits on his player card? Remember yesterday we were talking about how to write an equation. We found out that he started out with 120 credits and he was adding 8 credits for every game won, which would give him a total number of credits. So the question is, if he had 8 games and we said Ron started winning games today, or before he started winning games today, how many games had he won for which he had saved the credits on his game? This one, the equation is a little bit funny with this, and so we're actually going to have to disregard this concept for the moment. We're going to have to think about this. If he had already had 120 credits, he was getting 8 credits per game. 120 credits divided by 8 is going to be, if we talk about 120 divided by 8, that's going to be 15 games. So we know that Ron won 15 games before today. Okay. After Ron won his 40th game, 40. How many more games does he need to win to collect the prizes for 500 credits? Show your work and explain your reasoning. Well, now we can go back to this equation. We know that he wants 500 credits. He has 120 credits and he's earning 8 credits for every game. But we know that he also has 40 games that he's won. So we have a lot of information here. The question is, we probably don't want to start with this 500 right here. We know that he probably hasn't gotten enough. So let's just see how many points he's actually accumulated just after 40 games. We know that he takes that 120 games plus 320 games, and that tells me that he has 440 credits. That 440 credits, 500 minus 440, is going to be 60 credits left. And if I take that 60 credits, divide that by 8, I get 7 5/10. Ron has to win 5.5 more games to be able to collect. We're going to have to go ahead and increase that and say Ron must win in order to get all of his points. I know it doesn't say anything about getting half points or anything like that. We're going to have to round that up. Ron must win 8 more games to have 500. That's terrible. 500 credits. Okay. All right. Summarize what you know about this scenario based on your analysis. Be sure to include each item listed. The initial value of the independent and dependent variable in the context of the problem. Initial value was 0, 120. A sentence explaining the rate of change in terms of the context of the problem. Earns 8 credits per 1 game won. The final values of the independent and dependent variables. After 40 games, he had won 440 credits. Cool. Just a quick synopsis of what we had there. Quick bit of information. Now let's flip that and let's look at the table. So far, we've found all this information from a graph, and we've talked about writing a ratio of vertical to horizontal distances. However, you can also determine the same thing, the same slope from the table. So we're going to choose any different values from the independent. We're going to calculate the difference. We're going to choose 40 and 0, just because I want to go from high to low. And so we calculate the difference. 40 minus 0 equals 40. Now we're going to calculate the difference of the corresponding values in the dependent variable, but it's really important that the order of the values that we use for determining the other ones are the exact same. They're followed. So that means since I went from 40 to 0, I have to go from 440 to 120 in the same order. 440 minus 120 is going to equal, let's go back to my calculator. It should come out to 320. Oops. And now I can write a rate to compare them. 320 that compares dependent, 320 to 44 or 40. There's my rate, but now I want this as a unit rate, and that unit rate would just simply change it to a fraction, 320 divided by 40, which actually equals 8/1. Spoiler alert, our slope is exactly the same. This is awesome because that means that I did my work on both parts. I've confirmed that they're the same. So let's go ahead and just answer a couple questions here. We're going to look at each of the following examples right here, and we're going to find out, following the arrows to calculate the slope, was the slope calculated correctly? Explain any errors that may have occurred when the arrows were drawn. In this case right here, calculating the slope, 40 to 0 and 440 to 120. Well, we just showed that that was the same thing that we did. We calculated the slope, 40 minus 0 is 40, 440 minus 120 is 320. We looked at example 1, and we say, it's all good. It came out to a slope of 8. Example 2, we're going from 40 minus 25, which equals 15, and we're going 320 minus 440. 320 minus 440 is negative 120, and that should be a red flag right there. We haven't seen a negative number in here, but I see an increase in x and a decrease in y, which means that when I look here at example 2, negative 120 divided by 15 equals negative 8. I can't have a slope of negative 8 because that would indicate that he's actually losing 8 tokens or 8 credits for every game that he wins. This is no good. This is not the correct slope. It was not calculated correctly, because if we look at this, we found the difference moving from large to small and then from small to large. We didn't follow the same order of going, in this case, up on the left and then down on the right. This is finding the change in y. This is going to be one direction, and this is the other direction. It doesn't work. Example 3 must be correct because we see that we're finding the change going from small to large and small to large. The fact is, 12 minus 18, while that is negative 6, and 216 minus 264 is negative 48, the fact is, since I went the same direction, negative 48 divided by negative 6 is still positive 8. So a negative divided by a negative is a positive. What we have to see here in example 1, as long as we're calculating in the same direction, we will always get the correct slope. But as soon as you start calculating in opposite directions, you get the wrong slope. We've seen this before when we talk about the slope formula. The slope formula has to follow the correct order. We talk about this being y2 right here minus y1, and this is x2 minus x1. In this case, we followed the order right here, y2 minus y1 divided by x2 minus x1. In the second example, what we did right here is we went y1 right here, and this is y2. Actually, it should be like this. Yeah, this is x1, and this is x2. And on this one, we went y1 minus y2 divided by x2 minus x1. And you see how flipping them around in the order, not following the same order, gave us an inaccurate slope. Where again, over here, this is x1, y1, x2, y2. We went like this. We went y1 minus y2 divided by, check this out, we went from x1 minus x2. We followed the same order, and that's how we got the same slope. We have to calculate in the same order every single time. Whew, take a deep breath. I know I'm going really fast. This will continue to happen. Here's a great worked example of how to calculate the slope with the same information, with all the exact same steps, if you would much rather read it. But here's the thing. Does it make a difference which points you choose? Absolutely not. We can use the same process for any of the points as we go through. We repeat the steps. Perhaps instead of using these two, we wanted to go ahead and they use 12 and 216 and 25 and 320. We can do that with any other ones. And using the slope formula, we can always find the same slope, but we have to always follow the same order. Otherwise, we're going to get the wrong information. All right. Another new concept. We're going to talk about linear relationships in tables, meaning since we can use the slope formula, we can calculate the slope of the line, and we can find out if these are linear or not. So calculate the slope of each linear relationship using the formula, show your work. All we're doing right now is just calculating the slope to figure it out, to see if it's right. So I'm going to go with A. I'll go ahead and find it right down here. I'm going to pick this one as x1, this one as y1, and I'll go ahead and go x2 and y2. So when I take these two ordered pairs, I'm going to take the larger of the x's, those are always the y2s, and I'm going to go y2, 18, minus y1 of 9, divided by 16, follow the same order, here to here, here to here. 16 minus 4. And I go 18 minus 9 is 9. 16 minus 4 is 12. And I have 9 twelfths, which simplifies down. Divide that by 3 and that by 3. That's going to be 3/4 for my slope. Cool. Let's go ahead and go down here to this one. And we can go ahead. Order doesn't matter. So I'm going to go ahead and go from y minus y, 25 minus 40, 10 minus 55. What matters is that we follow the same order, change in y over change in x. And what I get with this one's going to appear to be negative. This is negative 15 divided by negative 45, but a negative divided by a negative is actually a positive. And so that positive, I know both of these have a common factor of 15. This would simplify down to 1/3. You have some other practice you can do with B, D, and F. Go ahead and take care of those. One thing that I would suggest to you before you actually get started, here's a little comment box. They said, do you think the rate of change will be positive or negative? Here's what we can look at. Positive and negative, think about multiplication and division. When you take a positive times a positive, you get a positive, or a negative times negative, you get a negative. In this case, we're talking about division, and we can remember that a negative divided by a negative is a positive, and a positive divided by a positive is a positive. So take a look at your change in y and your change in x. The change in y here is constantly increasing. So we see an increase right here divided by an increase over here. This would be a positive slope. Okay. Letter B is talking about this. The change in y, we see a decrease in y, while we see an increase in x, and a negative divided by a positive is a negative. So the slope for letter B would be a negative slope. And we can see that simply by finding the change in y over the change in x. D, I see that my y is actually not even changing. There's zero change in y. In my x, I see an increase, but what that matters is that we're doing this. 0 divided by any number is equal to 0. So we see this one as a 0 slope. When we look at letter C, we see a decrease. This is a decrease of -2. This one, -2, -2 over +1, +1, +1. I see a constant decrease in x and an increase in y. This is a negative slope. And that's just a quick way we can tell if it's negative or positive, or in this case, 0, because all of the y coordinates are the same. Let's take a look at that a little closer and talk about the proportional relationships as well. So which relationships in question 1 are proportional, and explain your reasoning. When we're talking about this question, how can I find proportionality? Proportionality has to have not only a constant rate, but it also has to have y divided by x is equal all the way through. It's the same rate all the way through it. So what I need to come up with is this. I'm going to check and see 9 divided by 4 is equal to 9/4 is equal to 2 25/100. And then I have 12 divided by 8 is equal to 1 5/10. This is not proportional. While I do have a constant rate where I'm constantly increasing on my y and increasing on my x, that value does not come out to be a proportional relationship because the y divided by the x does not equal k, or the constant of proportionality. So this one, no, letter A, is not proportional. When we look at B, we can do the same thing. We can go 25 divided by 7, and we get, or excuse me, this is letter C, 3 57/100 and some change. And then we can go 23 divided by 8, and we can clearly see those aren't the same values. This one is also not proportional. When we look at this one right over here, I would have to recognize the same thing, but I know right away it's not proportional for a different reason. I can see the y-intercept. This is not proportional because I know the line passes through 0, -2 on the y-axis, not the other. We can follow the same things right here and do y divided by x and y divided by x. So I'm going to look at this one. 40 divided by 55 is 72/100 repeated. And then 25 divided by 10 is 2 5/10. These ones are also not proportional. It appears that none of these are proportional. So take that in mind. Keep that piece there available to you. Think about this now when we're talking about positive slope. If a line is positive, then both values have to increase. When we're talking about this, notice the x is always increasing. But when we talk about a negative slope, then we're talking about an increase compared with a decrease. All right. So now let's talk about the relationships here. And we're going to sketch these relationships. What I would much rather look at is this. X is always the exact same. In this case, x is 1. This is a great representation of a vertical line. Okay, that means that there is no slope or undefined. Sorry, you can't see that. Look, in this one, all of the y's are the same. This gives me y equals 2. Well, what does that relationship tell us? We actually see a horizontal line or 0 slope, or we can say m equals 0. Quick reminder on those pieces. Almost done. We need to figure out if something is linear or not. Remember, linear means that it's a straight line. And to have a straight line, that means that we have to have constant rate and constant rate of change. The slope has to be the same all the way through. Calculating the slope is awesome. It's a cool way to do it. But I think that calculating the slope, it takes a lot of time. And I am going to show you calculating the slope here just to revisit one more time. We're going to go ahead and go like this. 28 minus 13 divided by 9 minus 4. 28 minus 13 is 15, divided by 9 minus 4 is 5. This slope is equal to 3. Letter B, 34 minus 28 is going to equal 6. That's my change in y. And then my run, 11 minus 9 is 2. My slope is 3. Cool. Pretty good so far. 47 minus 34. That's minus 7, minus 6. That's going to be a difference of 13. Yeah, that's got me a little worried. And then 16 minus 11 is 5. And 13 divided by 5 is not 3. And that just tells me right here, will the ordered pairs listed in the table form a straight line? No. There's no constant rate. And it's because of this. 15 divided by 5, while that is equal to 6 halves, it is not equal to 13 fifths. It's not going to be a constant rate all the way through. So there's not a linear relationship. So let's look at these other ones and decide, is there a linear relationship? And this is going to be a lot faster with what I'm going to show you. From 7 to 13, that's increasing by 6. Okay. 13 to 16 is increasing by 3. 16 to 34. I'm not totally confident in this one, but I believe that it's going to be 18. It is 18. And I want to look at the change in the y. I see an increase of 4 here, an increase of 2 here, and an increase of 12 here. And so now I look at my ratios, change in y over change in x. 6 fourths, 3 halves, and 18 twelfths. And I need to make some comparisons. I know that 6/4 can reduce to 3/12 just by simply taking a scale factor of 1/2. Half of 6 is 3, half of 4 is 2. I know those two are equal. I know that 6 is a common factor for 18 and 12. 18 divided by 6 is 3, and 12 divided by 6 is 2. That fraction is equal. And since all of these rates in here are equal, right, 6/4 is equal to 3/2 is equal to 12, 18/12. This is a linear relationship. Kind of cool. Looking at this one, the change in y, this is change of 1, 1, 1, 1. It's just constantly increasing by 1. So over here, if I see that constant increase being the exact same all the way through, then I also have a linear relationship. I see from 33 to 40, that's an increase of 7. 40 to 47, increase of 7. 47 to 54, plus 3 is 50. 4 more, 7 and 7. That's pretty awesome. This one's also linear because I have a slope of 7/1 all the way through. Kind of nice. What we call this is a thing called the first differences. The first differences is when we find that consecutive difference all the way through when we're talking about a consecutive pattern. A consecutive pattern means in order 1, 2, 3, 4, 5. We're talking about the consecutive values of a dependent that are being related to the consecutive values of the independent. So when we talk about these first values, what we're going to look at is we're going to process this and find out subtracting the consecutive y values in the table when the x values are consecutive integers. So that's the important piece. These are consecutive integers, 1, 2, 3, 4, 5. You notice that we have 1, 2, 3, 4, 5 all the way through. So that means that these values of y also have to correspond with that. 25 to 34, we're going to go 34 minus 25 is 9. So that change here is 9. 34 to 45, 45 minus 34 is 11. Oh, that's already different. And because that's already different, that means that this is non-linear. It also means that it's not proportional. Okay? Looking at the next one, I see still the increasing of 1 in B, but now right here I'm seeing minus 4, minus 4, minus 4. Very good. Minus 4. Cool. Since I see the exact same pattern all the way through, I can say that these are linear. Awesome. The next one, 1, 2, 3, 4, 5. So right here, I see an increase of 3, increase of 5, nonlinear. Because there was already a change right here. But then you might say, but there's an increase of 7 and an increase of 9 right here, and there's a pattern. It's a pattern, but it's not linear because the rate is not constant, right? The last one, plus 3, plus 3, plus 3, plus 3. Constant rate of 3/1. This is linear. This one right here was a linear constant rate of negative 4/1. So look at the first differences and looking at that constant rate. If there is not a constant rate, then there is no linear relationship. Whew, and we made it. Good job. This one can be on your own. This is a little bit of extra. Talk, talk, walk the walk. That one will be up to you. Show me that, and I can show you some extra credit. What we need to recognize from here is we need to remember the slope formula is y2 minus y1 divided by x2 minus x1 to determine the rate. We're going to find the differences, but we have to follow the same direction. We need to really, really absolutely remember horizontal lines have a slope of 0 and vertical lines are undefined. Your job for your homework is this. Question number 1, you need to look at each of these and decide if which table or tables represents a slope of positive 2. Remember how earlier we talked about having an idea of whether it's positive or negative from the beginning? Looking at this one right here, x is increasing, y is decreasing. That tells me the slope is negative. This one is not. Table 1 does not have a slope of positive 2 because it's a negative slope. X is increasing, y is increasing. This is a positive slope. There's a contender for being a slope of 2. And then this one, x is increasing, y is increasing. That one is also a possibility. Find the slope. Again, remember thinking about that first, going back to the first differences, I see consecutive numbers right here. So is there a consecutive slope, 3, 5, 7, 9? I think so. Over here, these ones aren't consecutive, but it is still possible that this is going to be linear and it could still have a slope of 2. Don't forget about that. There's a change of 3, a change of 4, a change of 2, and then 8 to 14, that's an increase of 6. 14 to 22 is an increase of 8. 22 to 26 is an increase of 4. Take a look at those constant rates, change in y over change in x. Is that a slope of 2? Looking at number 2, you're supposed to calculate the rate of change between the points listed in each table and determine if the table is proportional. I don't care how you do this. They're suggesting that we want to use the slope formula for this one. I find the slope formula to take a lot of time. However, we can do that slope formula within the table. We know that each of these tables do represent linear relationships. However, we don't know if they're proportional. What we can do with this is we can go ahead and go like this and find the slope, calculate the rate of change. 35 minus 14 is 21, and 5 minus 2 is 3. The rate of change is 21 thirds, which equals 7. It is a good practice to go ahead and try this twice just to verify that we do have something that is going to be a proportional, or excuse me, not proportional, but is going to be linear. 49 to 70, 49 minus 70. This one right here is going to be negative 21, going 49 minus 70. 7 minus 10 is a negative 3. Negative 21 divided by negative 3 is equal to positive 7. I know that my slope is 7. So m equals 7. But the question still remains, is this proportional? Remember what we talked about with proportionality, where we take y divided by x, and if we have the exact same quotient each time, then we know we're proportional. 14 divided by 2 is 7. 35 divided by 5, 7. 49 divided by 7 is 7. 70 divided by 10 is 7. We have the exact same constant rate here, y divided by x. We know y divided by x equals k, and we know k is equal to 7. This one right here, letter A, is proportional. So you need to have two answers, slope and a proportional relationship. Maybe B, let's start with proportionality. 50 divided by negative 10 is negative 5. 10 divided by negative 2, negative 5. Negative 20 divided by 4, negative 5. Negative 70 divided by 14. I have a hunch that that's going to be negative 5, but let's just double check. It is negative 5. So right now it's looking proportional, but to be proportional, it has to be proportional and linear. So let's double check. From 50 to 10, this is going to be 40. And from negative 10 to negative 2, this is going to be increasing by 8. And 40 divided by 8 equals 5. Cool. That's the slope there. When we talk about, or a constant rate there. When we talk about, oh, wait a minute, I did something. I did something right. This is a negative 8, so I have my slope is negative 5. 10 to negative 20, this is a decrease of 30, negative 30, and negative 2 to positive 4 is an increase of 6. Negative 30 divided by positive 6 is going to be a negative 5. And we can check the same thing right here. We know right off the top, negative 5 is my slope, and this is proportional. Looking at the next one, negative 24 to 48 is a really big jump. So let's go ahead and look at this. 48 minus negative 24 is 72. And negative 1 to 2. 2 minus negative 1 is positive 3. 72 divided by 3 is 24. So I know my slope, m equals 24. But now I have to go ahead and go with these. Negative 24 divided by 1 is positive 24. 48 divided by 2 is positive 24. I want to double check 90 divided by 4 is not 24. Well, since y divided by x, this one was right here. K was equal to 24. K was equal to 24. K was now equal to 22.5, which means that this is not proportional because we didn't keep the same constant of proportionality. You get the idea. Do that for D, E, and F. On the next page, and a little bit more for you is just some review from previous lessons. Tell me the slope of A, tell me the slope of B, tell me the slope of the equation y equals 2x, tell me the slope of 5, 6 is equal to yx. Remember that y divided by x is the same thing as k, and k is our constant proportionality. Hint, hint, nudge, nudge. Number 2, consider the graph shown and tell me what happens under a rotation, and then tell me what happens under a reflection. I'm going to probably make letter B an extra credit one, but we'll see what happens. You're doing great. Thanks for hanging in with me. Went through all your homework with you and the whole lesson. Watch this as many times as you want. Speed it up, slow it down, rewind it, fast forward it. It's up to you. Just please get the work done. Email me with questions. Have a great day.